Okay, I want to look at this problem that was sent to me. It's a question on the MyOpenMath problems. So this is a graph of f of x, and we have to, on the same axis, sketch a graph of, oh, that's my mail, sorry, sketch a graph of the inverse function f inverse of x. Okay, so the thing to realize about this, and actually it's probably on here somewhere, um, that when functions are inverses, well, actually it's this relationship here that's relevant. If you have an ordered pair on the graph, and that ordered pair, say, has coordinates a, b, then on the graph of f inverse, you're going to have the pair b, a. In other words, they're gonna switch, and that makes sense because it's an inverse function. Like for example, inverses. If you have, as just a little example, if you have the pair, say 1, 5 on f, then the ordered pair 5, 1 is on the inverse function, because that's what inverse functions do. So you have a domain set here, and the function maps that domain set into a range set. And say in that particular example, say in the domain is 1 and 5 is a range value, and f maps 1 to 5, the inverse function will map 5 back to 1. So that's why the reverse of the ordered pairs are on the graph of the inverse function. So for this particular example, I just indicated these two. I mean, it's just so easy to see these 2 points. This point is the ordered pair -2, 0, and this point is the ordered pair 0, -2. So since those 2 points are on f of x, the inverse function, the pairs on f inverse of x, which is what that's supposed to be, will just be the reverse of these. So -2, instead of getting mapped to 0, 0 will get mapped to -2. And instead of 0 getting mapped to -2 on f, f inverse will map -2 to 0. So again, you just reverse the order for the inverse functions. So that means to draw the graph of the inverse function, I'm just going to, the functions align, so the inverse function will pass through these 2 points, and if I graph these 2 points, then I'm graphing the inverse function. So 0 gets mapped to -2, so that's this point, and then -2 gets mapped to 0, that's this point. So for this particular function, the graph of the function and the graph of the inverse are actually the same graph. Okay, so in part B, we have to use the graph of the inverse function to evaluate f inverse prime of -3. So for the second piece here, let's see, so for the second part, what we're trying to find here is f inverse prime of -3. Okay, so we're going to use this result, and the result is here somewhere. Oh, this result in the red box. We're using this result. So this result says f inverse prime of 3 would be equal to 1 over f prime of whatever value maps into -3, right? Because this assumes that the ordered pair AB is on the graph of f of x. So here, so what's the point? So what's the pair then? This is going to be equal to, according to that red box, 1 over f prime of a, where a is that value that gets mapped into -3. That ordered pair is on f of x. Okay, so that's kind of interesting. Now we can figure that out. However, in this particular case, the function is a line. So, f of x is a mx plus b. So, what's the derivative of this function? So here, I mean, it's very easy to see here. The equation of that line is pretty simple. You could do it by inspection. The slope is -1, and the y-intercept is at -2. So y here is equal to minus x minus 2. So that's f of x. And why is that relevant? Because when you take the derivative of that function, it's just going to be, for any linear function, it's just the slope, right? Because the derivative of the constant is 0, and the derivative of mx is just m. So f prime is -1. So actually, in this problem, we don't even need to care about what a is, because there's, f prime of x is a constant. So if we use this result, this will be equal to 1 over -1, which is -1. So we would put that in here. But I have no keyboard, so I can't actually do it. But anyway, that's the result that you would have here. If you have further questions about this, you can send me an email.